Dear friends, students, and of course kids, this may be the new upgrade what I found in deriving the formula for the cells which are connected in series, specifically from the CBSE book. What up till now we have done that the two cells are connected in series as this, with their individual EMFs are E1 and E2, whereas an internal resistances are R1 and R2. The total current what it flows, because of them it's considered to be as I, and the current from each of the cells individually is I1 and I2. What was done is VA and VB are the voltages at the terminal of two cells parallel combination, and they've done something like this: VA minus VB, and the Kirchhoff law has been used, and lots of algebraic expression what it comes in a way. Yesterday when I was shuffling with whole of this, I found some shortcut. What is it? I'll say simply E1 upon R1, I take it as I1. I2, I'll take it as E2 upon R2. Well, as a net I will gonna be I1 plus I2 as usual. So I'll just substitute the values E1 R1 plus E2 R2. After taking an LCM, it will be R2 E1 plus R1 E2 divided by R1 R2. This comes out to be as an I. Well, then if in case if I consider the overall combination as a simple cell with an E equivalent as an equivalent EMF, well as an R as an total equivalent internal resistance. So I'll get I is equal to E EQ over R. I can substitute in here. So I'll get EQ, over R is equal to R2 E1 plus R1 E2 divided by R1 R2. Now suppose if I wanted to make a comparison between these two of these quantities, all the problem what we have is here it's an EMF, and here actually both the numerator EMFs has been multiplied by the resistances. So Houston, we have a bit problem. So what the best I can do it, I can get rid of this R1 R2 as this. I need a linear expression of the resistances to be divided in the denominator. So I can think about as R2 E1, as I said, R2 E1, plus R1 E2 divided by, simply I'll say R1 plus R2. So I divided by R1 plus R2, so I'll multiply by R1 plus R2 divided by R1 R2. Well, then why specifically I must have thought about R1 plus R2? Because this gives some sort of a connection between the parallel combination of the two of the internal resistances. Well, then even the cell, it looks connected in parallel. So I'll guess about the parallel combination of the two of the internal resistances, and I'll compare now E equivalent upon R with this. So now 1 upon R I can compare with this, and E equivalent I can compare with that. So basically I'll get E equivalent as R2 E1 into R1 E2 divided by R1 plus R2. Well, and of course value for the equivalent internal resistance will be R1 R2 upon R1 plus R2, which comes out to be as a parallel combination of the two of the internal resistances. Well, then that was like that. Well, this looks a bit rational than compared to the algebra, whatever has been worked out with CBSE books and all. So I felt like sharing it. See how it goes. Thank you very much.